Section 12.7, increasing and decreasing functions. Everything you need to know here is contained in these two black bullet points, but the way that they're written with all the algebraic notation isn't the clearest way of thinking about it. If you get the idea of what increasing and decreasing means, then tie it up to what those black bullet points say, you've got the idea of the whole section. So increasing and decreasing really mean what you'd expect. If you're moving from left to right across the page, increasing means the line is moving upwards, doesn't it? Okay, this is an increasing. If I'm walking from left to right, I'm having to walk uphill to walk up this function. So a function that's doing this is increasing, a function that's doing this is increasing. From left to right, I'm going uphill. A decreasing function, I've made a bit of a mistake there. A decreasing function has to be going downhill. So something like that, something like this, anything that's wibbling its way downhill and never coming back uphill. And again, uphill if we're moving left to right on the page, okay? So what does it mean for a function to be increasing? Well, all of these functions, look, the gradient is positive. The gradient is given to us by the derivative or the gradient function. So if the gradient is positive, then we say the function is increasing. If the gradient is negative, we say the function is decreasing. What about functions where it changes? So this sort of function here, well, every time it turns round, it changes. So here, this function is increasing here, then it starts to be decreasing down here. Then here we've got an increasing function again, then a decreasing function, and then a slowly increasing function there, okay? So a single function doesn't have to be just an increasing function or just a decreasing function. It can be an increasing function for these values of x and decreasing function for those values of x and so on. And that's what these bullet points here say. So we're bearing that in mind. Let's read through these bullet points. I'll just remind you before we do of this notation, this A, B notation in the square brackets means from A up to B. So if I said 2, 3, then picturing that number line, not 1, 2, 3, 4, from 2 to 3 in a set of square brackets means this interval here from 2 up to 3. Okay, there are conventions with the square brackets and with curved brackets, with square brackets, where these mean slightly different things, but we're not going to worry about that as far as this textbook goes, as far as this course is concerned. From 2 to 3 means from 2 up to 3, and we're not going to worry about whether it's an inclusive inequality or an exclusive inequality. So let's have a look at it. The function f of x is increasing on the interval from a to b if f dash of x is greater than or equal to 0 for all values of x such that a is less than x is less than b. Okay? So if x is between a and b and the first derivative is positive, then we say the function is increasing. Okay? Function's going uphill. Same thing, if x is between a and b and the first derivative, the gradient function, is negative, then we say it's a decreasing function on this interval from a to b. If the function is increasing everywhere and it never turns around and becomes negative, we can just call it an increasing function. If it wibbles around, goes up and down, then we have to specify the intervals where it's positive, where it's increasing, specify the intervals where it's decreasing. There are questions here. Now, when you come to the exam, it's fairly unlikely that they're going to ask you a question like example 13, just find the interval where it's decreasing. It's much more likely that, that they want us to know this idea of an increasing or a decreasing function and the proper definitions of them so that we can employ them in context as part of more complicated questions. Exercise 12G and those two bullet points and a bit of intuition of what's happening should be more than enough, I think, to get you all the information you need for that.